We all want the same thing from web automation. Type a single natural language prompt, hit enter, and watch an AI navigate a multi-step process for us. Right now, we try to achieve this by making AI act exactly like us. We force the agent to take a screenshot of the web page, look at the interface, and guess exactly where the submit button is located. But websites are dynamic. A responsive layout shifts, CSS updates, or a pop-up overlay suddenly appears, and the agent's visual coordinates are rendered useless. It clicks the wrong spot, the cart gets abandoned, and the task fails. Treating an AI like a human with eyeballs makes navigating the web fragile. This unreliability is paired with a massive, hidden back-end cost. Processing those screenshots requires sending heavy image data back and forth for every single action. This chart shows how fast that visual data adds up. Evaluating these screenshots can consume up to 143,000 tokens in a single turn, out of a standard 200,000 token context window. That level of token bloat burns through server resources. It makes scaling these AI features to millions of users too expensive for most production environments. Visual web automation is broken on the front end and economically unsustainable on the back end. The alternative is a browser-native standard called the Web Machine Context Protocol, or WebMCP. Instead of building expensive parallel backends or relying on screenshot analysis, WebMCP uses simple, lightweight annotations added directly to your existing front-end code. Developers inject clear declarative attributes into UI forms, explicitly defining tool names and descriptions in the HTML. This creates a semantic contract. The agent doesn't guess visual locations. It reads the code, locks onto the declared purpose, and executes the action. WebMCP turns your existing front-end into a native API that an AI understands instantly. Modern sites, especially single-page applications, are highly dynamic. Menus open and forms appear without the browser ever fully refreshing. To handle this, developers use hooks called Provide Context and Clear Context. These provide live updates, informing the agent which tools are active at any given moment. However, a list of tools is static. To complete a complex task, the agent needs the specific logic that connects those buttons in the correct order. Websites can now serve text-based recipes or skills directly to the agent. This teaches the AI the exact step-by-step logic required to complete a domain-specific task on that platform. WebMCP provides the site's layout and the exact turn-by-turn logic to navigate it. Moving from visual guessing to native semantic tags changes the business case for AI integration. This chart compares token usage per turn. By eliminating image processing, WebMCP token consumption drops by 89% compared to screenshot-based automation. For product managers, this metric flips the script. AI integration shifts from an expensive infrastructure challenge to a lightweight feature. Flawless, single-prompt user automation is now economically viable at scale. Because this is a low-overhead front-end edition, the implementation process is fast. Developers can use AI coding assistants like Cursor or GitHub Copilot to read existing UI components and automatically inject semantic attributes into the codebase. You can then feed product documentation into a tool like Claude to automatically draft the step-by-step skills recipes for the agent. Finally, developers set up safeguards to require user approval for sensitive actions like payments and test the flow in a Chromium browser. Annotating the front end turns existing interfaces into reliable, low-cost targets for web automation.